So in part one, you're doing the same experiment 3 different times, and what you're changing is the concentration for your IO3 minus 1, your iodide ion. So you have to copy your initial concentration for your potassium iodide, the initial concentration for the acid from the label. And you see how I have them in different colors. Both of them are labeled as C1 because that will be your initial concentration. But you have 2 different solutions, so you have 2 different initial concentrations. So you have an initial concentration for the potassium iodide, that number from your label, and you have an initial concentration for the acid, that number you can copy from the label. I'm using the green one for the acid. Since we're trying to determine the order for your iodide, in this part, the volume for the acid that you're using in your 3 different samples is the same because we're keeping the concentration for that one constant. The concentration that we want to have different is the one for potassium iodide. If you have different concentrations for the potassium iodide, that's the data that you're using to determine the order for your potassium iodide. So in the table, you have just the volumes that you can copy from your lab manual. For your first trial, label as A, you're using 5 milliliters of the acid, 39 milliliters of water, and then 6 milliliters of your potassium iodide. So you're calculating concentration, and that's for your dilution, okay? For the acid. And to calculate concentration for the dilution, we're using the equation for dilutions. So we're solving that equation for C2, which is what you want to calculate. So C1 is the concentration that you have for your acid times V1, which is how much acid you're using, and all of that divided by a total volume. The total volume for all of your samples is going to be 50 milliliters. If you add 5 here plus 39 plus 6, that gives you 50. If you add 5 plus 35 plus 10, that gives you 50. Same thing for the last one. You have 5, 14, and 31. When you add all of that, that will give you 50. So the final volume for all 3 samples is 50. So going back to your C2, you have C2 here. And for the first one, your concentration, C1 from your label times your V1. For the acid, you're using 5 milliliters, and all of that divided by 50 milliliters. Okay? So remember, where I'm writing C1, you should have an actual number that you're copying from the label. So it's the same calculation for A, B, and C. Exactly the same. So you're going to have the same concentration for the acid in your 3 dilutions because your volume 1 is the same for all 3 of them. Your concentration 1 is not changing. That's from the label. Your final volume is 50 for all 3 samples, so that's not changing either. And the initial volume, or how much acid you're using in each sample, is the same number for all 3 of them, which means that your C2 for all 3 samples will be the same. That's not going to happen with your potassium iodide. For potassium iodide, when you're calculating your C2, you're using your concentration 1 again from the label. So that will be that number right there, C1. Your V1 is how much you're using for KiO3. For the first sample, that will be 6, and then your V2 will be 50. So you're using those 3 numbers to calculate C2 here for the first one. For the second one, you have the same C1 from the label, that one. Your V1 now is not 6, now we're using 10, and your final volume is still 50, so you get a different concentration. And then the last one is the same C1 for KiO3. Remember, you're calculating for KiO3, so same concentration for KiO3. Your V1 now will be 14 for that one, and then your V2 is still 50. So you have your concentrations here for your acid and the potassium iodide. The time in seconds is your experimental data, and then with the time you can calculate the rate. If you do 1 divided by the time in seconds, that will give you the rate. Okay? So I changed my number here. That should be a 28. So 1 divided by 28 will give you like 0.0356, and that's still seconds to the minus 1. So that's how you calculate the actual rate. It's just 1 divided by the time in seconds. Now, to determine the order, right, which is the last thing that you want to find out, the order, you can do a graph, and then depending on the shape of your graph, you're going to determine if the order is 0, 1, or 2. So in your graph, you're plotting your rate. You have rate for all 3 samples. So remember to choose an increment, right, for your experimental data, depending on the lowest number, the highest number that you have for the rate. And you're going to choose a specific increment. You're not using the numbers that you're getting. You're using specific increments in your axis, and then you're going to plot the numbers that you have. So the rate goes in your y-axis, and remember the rate is what you're calculating, doing 1 divided by the time in seconds. And then in your x-axis, you're plotting right there the concentrations. Since you're trying to find out the order for KiO3, you're plotting the concentration for KiO3. Concentration for the acid will be the same, so you're not trying to find out the acid, you're trying to find out the KiO3. So you have your numbers, like you choose your scale, then you prepare the graph, and now you're going to start adding your numbers in there. You're going to check how much is the rate with in your sample with a specific concentration, and you're going to start putting dots in your graph. If your graph looks like a flat line, it means that the rate is independent on the concentration. You see, the rate is not changing. The concentration is changing, but the rate stays the same value. That is a 0 order. If your graph looks like a straight line with a positive slope, it means that your order is a first order. And then the last option that you have, it's if your line looks like a curve like this one here, it means that your order is a second order. Okay? So depending on how the graph looks, you're going to choose your numbers for this part here as a 0, 1, or 2. It's one of those 3. Now moving to the next part, which is part 2, you're doing the same experiment, but in this case the concentration that is changing is the concentration for the acid. The concentration for the potassium iodide remains the same because you're not looking for the order of that one. So the concentration is different for the one that you're trying to determine. So I just wrote the numbers from the table in the lab manual, your volumes. The label will tell you the concentration for your potassium iodide is the same that you have for part 1. The label will tell you the concentration for the acid, and again the same number that you have in part 1. And we're doing exactly the same. We're calculating your concentration in the dilution. The total volume for all 3 samples is 50. Your initial concentration is from the label, and then your volume 1 is the volume that you have in your table. So if you're trying to find out the concentration of the acid in your 3 samples, D, E, and F, you're doing your initial concentration from the label times the volume. For the first one, it's 6 milliliters. And the final volume is 50. So now you move to the second one. Your initial concentration is from the label. Your volume 1 is 10, and your volume 2 is 50. And you can calculate all 3 concentrations here. The one that you have with 6, with 10, the third one, C1 from the label, B1 now is 14 and B2 is 50. So you have your three concentrations for the dilution that you're preparing. And now you're calculating the concentration for the potassium iodide in the same way. You're using your dilution equation, you're solving for C2. Okay? C1, you copy that number from the label. V1 is what you have in the table. So you have that for your first sample, V1 is 10 milliliters, your V2 is going to be 50 milliliters. Then the second sample, you have concentration 1 from the label, and then you have your volume 1 as 10, and your final volume is 50 again. And then the last sample, concentration 1 from the label times your volume 1, which is also 10, divided by your final volume, which is 50. So all of your concentrations here for the potassium iodide are going to be exactly the same. So you're measuring your time, that's your experimental data, and you calculate the rate in a similar way to what we did before. You do 1 divided by the number that you have for your time here in seconds. So you have to convert your measurements of time to seconds, and then you calculate the rate, 1 divided by that number of seconds, that will give you the rate. And again, you're doing your table, your graph, okay? You have to include the graph in your report. If the concentration changes but the rate remains the same, that's a zero order. If the concentration changes by the same factor that the rate, if the rate changes by the same factor that the concentrations are changing, then you have a first order. And then the last one is a second order. If the rate is changing, if the concentration is changing by a factor of 2, for example, the rate will be changing by a factor of 4, which is 2 squared. That's what makes an order equal to 2. So again, you have to prepare your graph. You have rate in the y-axis, you have concentration in the x-axis, and depending on the shape of your graph, you can choose what's the order for this specific reactant here. It can be 0, 1, or 2. Now in part 3, you're just looking for a relationship. You're looking at what happens to the rate when the temperature is changing. So you have a sample with cold water, a sample with hot water. You're determining the time that it takes for your solution to become dark blue, and you can calculate your rate. You need to look at your numbers and compare those two numbers. Which one is faster, the one that you have in the cold water or the one that you have in the hot water?